Hello everybody, this is Jose Marchesi. In this short video, I'm gonna talk a little bit about a relatively new facility that appeared a couple, 2 or 3 years ago, which are the terminal hyperlinks, and how we make use of them in order to improve or to enhance the user experience in GNU Poke when using the command line interface of the program. So, terminal hyperlinks. All right. For many years, the terminal emulators and terminal implementations, they have support implicit links, right? An implicit link is basically, well, when a program or the user prints in the terminal something that looks like a URL, for example, well, a URL for HTTP or FTP or the like. Well, the underlying terminal, well, it recognizes it by the form, right? If it starts with http:// blah 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 / blah blah blah. I mean, if it lexically follows the rules of what a correct URL is, then the terminal, some terminals, they recognize those things, and then they decorate the URL in the screen using underline or some other decoration, and the user of the terminal can click on that link on that hyperlink, and then the terminal will react by doing some action, right? In the case of an HTTP hyperlink, the right action would be to start to launch a web browser and direct it to that URL. So we can see it. This is a terminal. This is a GNOME terminal, and if we print to the terminal a URL, for example, this HTTP one, then we can see that the GNOME terminal recognized it as a URL, and then implicitly it did the right thing for us, which is, you can see that the pointer turns into a little hand here, and if I press Control and then click on it, then this URL gets open in some web browser that you cannot see in the video because it's out of the area in the screen that I am including. But it is doing it. It's actually opening the GNU.org website in my web browser. Well, this is what I have called here support for implicit links, right? Why? Because the program that is generating the link, in this case the program echo, it doesn't know, right, that it is generating something that is clickable. It is the terminal that recognizes certain patterns and then creates implicitly those links. Again, this has been around in many terminal implementations for many years. However, back in 2017, so not that long ago, Egmont Koblinger suggested and designed a way to using explicit links, right, instead of, or additionally to the implicit links that we have seen now. Basically, what do this means? This means that this time it is the programs that are emitting explicit hyperlinks by using sequences of escape characters. Terminals, since the old VT terminals, they have been using sequence of escape characters, which usually are not visible, in order to do requests to the terminal, like scroll up one line, scroll down one line, change the property of the next characters to underline or bold, or stuff like that. That is done by sending to the terminal escape characters. Now, what Egmont did was to expand, to introduce a new kind of escape character, of escape sequence, which is the escape character, this close brace and 8, to introduce a hyperlink, right? So then this is an example here of a shell function that will emit a hyperlink using this, what we will call this href, and as the second argument some text, right? So this will result, if the terminal supports terminal hyperlinks, explicit ones, printing this in the terminal will result into a clickable hyperlink. So this is what terminal hyperlinks are about. So in this video we are talking about the explicit version of them, not the implicit ones that have been around for many years, which are useful but not as interesting and the explicit ones. We will see why right now. When in one of the rabbit herd hacking weekends, which is a meeting that some friends we have from time to time, Bruno Heibel introduced the terminal hyperlinks to us, and we very quickly thought about using this new support in order to enhance the command line applications, right? Why? Because, yeah, sure, I mean, those terminal hyperlinks, they can be used for emitting hyperlinks for HTTP or FTP or file : / you know, that will make the terminal application to open whatever handler for them. But the terminal hyperlinks can also be used for a program, a command line program or a textual program, to emit hyperlinks that are clickable by the user in order to establish a two-way communication with the user, right? So, for example, the application may want to ask something to the user. The traditional way of doing it for command line applications is for the application to print a prompt and then let the user type the answer there, right? But we thought, well, what if the command line application could actually print the question to the user and then to print two hyperlinks, one for yes and one for no. So then when the user clicks on yes or she clicks on no, then basically the application will be notified of that in a socket. And we thought that this could lead to a very comfortable way for command line application users to leverage basically the mouse, right? So to achieve that purpose, we designed in one of those meetings, we designed in an afternoon a little protocol that we call the app for application protocol, right? This app protocol is the one that we are using in Poke right now, but since that initial version, Bruno, he evolved it into two different proposals, app start and app socket, and well, you can see in the URLs there in this slide. Those are the emails describing those proposals. And this app protocol, it is basically implemented by a very small and simple C program, which is called app client. How does this work? Like this. The idea is that you have a program which is using a terminal. So the typical program here, it will be a command line interface, like Poke, for example, but it could also be a shell or, I don't know, I mean, GNU Octave or any other program using a command line interface. And, well, basically, the program emits hyperlinks using the escape characters sequence that we described before. And the hyperlink is not an HTTP or an FTP or anything like that. It is an app colon slash slash. The hyperlink, it has a host part, colon, a port part, and then a slash, and then a payload. Right. This is literally, so this URL here, this is literally what the terminal gets, and the terminal prints, in itself as the href for the terminal hyperlink, right? Now, the terminal, when it gets the hyperlink from the program to get printed, it looks at the protocol, and then it says, okay, this is an app. This is the app protocol. So it knows that when the user clicks on this hyperlink, then the terminal runs the app client program, which again is a very small C program that receives, the whole URL. Well, actually, this part, the host, port, and payload, and basically it opens a socket connection to the program, which is listening in this host at this port, because we were told that by the program itself in the URL, and it sends the payload back to the program over the TCP socket. And this is all. This is how it works. So note that we have achieved a complete closed loop here, right? So this program can print the hyperlinks in the terminal, and then the user, by clicking on them, can actually tell the program that that hyperlink got clicked and pass in the whatever payload. Now, what is the content of this payload? Well, it's not restricted. The app protocol says nothing about it, because this payload is up to the program, to the particular program. As we will see in POC, we use one kind of payload, but other applications we use different payloads. So this is how it works. Now, well, really that was all. I mean, about terminal hyperlinks. I mean, there is no more about them than that. Now, when it comes to POC, in POC we are providing different ways to interact with users and to interact with other programs, right? Basically, POC, the implementation is split between a libpoc, which contains the incremental compiler and the IO subsystem and many other components of the core components. And then there is an application, a program, which is called POC, which uses libpoc that provides a command line interface, right? Which is built in the POC program. The way we support, or we will support, because those have not been written yet, other kind of interfaces other than the built-in command line interface, is that we are providing a machine interface from POC, which is already implemented, that using JSON, as an intermediate transport and so on, the machine interface, the idea is that other kind of interfaces for POC, like textual user interfaces, graphical user interfaces, web-based user interfaces, or Emacs, can communicate with the POC program and command it using the machine interface, right? But note that the only interface that we are providing in POC is the CLI, the command line interface, which is built in POC. So this means that the primary usage of the program, we expect it to be the command line interface, at least until other kind of interfaces appear, right? So that is why we wanted to use terminal hyperlinks to improve this command line interface experience in POC. This is the main purpose of those hyperlinks, but as we will see later, POC programs and scripts, they can also print their own hyperlinks and act on them, which is pretty cool, I think. Okay, so what is the payload that we use in POC for the hyperlinks? We will see in 5 minutes. We will see examples, live examples of all of those kinds. But we have insert hyperlinks. We call them insert. that basically when the user clicks on one of those hyperlinks, some given text, which is part of the payload, gets inserted in the prompt, in the poke prompt. As we will see, this is useful, for example, to print, to include at the prompt things like addresses or offsets of some stuff we may be interested in. We will see it later. Also, we have execute hyperlinks. In those hyperlinks, the payload also is a string, is some text. But in this case, when the user clicks on the hyperlink, this text is executed as a command, exactly like if the user had typed that text in the poke prompt. And then, well, you are given the result. Again, we will see an example right now. Now, and the third kind is the closure hyperlinks, which is very much like execute, but instead of executing some pre-existing string as if it was a command or a poke statement, what it does is that it calls some given poke function, which are also actually closures. That's why those hyperlinks, we call them closure hyperlinks. And that's it. Now, how does a URL in the app protocol looks like for poke? Like this. As you can see in this example, this is app/:://. Then we have the host name, this is the name of my local machine. This is a port. This is the port where the poke that printed this specific URL is listening for connections. And then the payload. What is the payload? A number. It's just a number. I mean, we choose to not expose details of the different kind of hyperlinks in the payload, and therefore, basically, internal in poke, each hyperlink is identified by a token or a number, and what we put in the in the terminal hyperlink is this token. It's not, for example, the text that is going to be inserted, or not even what kind of hyperlink is this. It's just the token. All right, so this was it about terminal hyperlinks in general and about poke and why we are excited about them. And now it's time to see those things in action in the context of poke, of course, with the hope that you will find them interesting too, and you may maybe consider using the app protocol and hyperlinks in your own programs. Okay, here we go. Well, the first thing that we will do is to start poke itself, and then immediately we notice something. We notice here this message, which is the edge server listening import blah blah blah. Well, basically this is the port where the hyperlink servers of poke is listening. So remember the explanation before. When we click in a hyperlink that has been generated by this poke instance, the app client little program will basically open a connection to whatever port in the hyperlink, which will be this one. So we just launch poke, and we can already see some hyperlinks here. Those are not implicit hyperlinks. Those are explicit hyperlinks, right? So generated by poke. The first one that we can see here is a URL. It's a URL which is an HTTP URL. And we can see in the alt text that it is pointing to GNU.org licenses GPL HTML. Now, if we control click this link, then it will open a web browser pointing to this URL. So this is one example of using textual terminal hyperlinks to just emit an HTTP link. Okay, this is interesting. It works, but it's actually somehow boring. So the next hyperlink that we can see here is this one, and this is a completely different one. This is an app hyperlink. So basically, this is one of those kind of hyperlinks that when you click it, a message is sent to the running poke to act on it somehow. Now, as you can see in the alt text here, the token number for this hyperlink is 0, right? And again, okay, in the URL there is 38429, which is the port where the hyper server is running. That should not be a surprise. So I can tell you that this hyperlink here, .help, it is of the kind execute. And the text that is, the command that is it executes is .help. So if we control click on it, observe that it is like if we would have typed in the prompt .help, and then, well, it's showing us all the available help topics in the help system. Now, the output of the .help command, it includes hyperlinks itself. So for example, we could control click on them if we wanted to elaborate, right? Okay, no, I want help, but I want help about the Scrabble command, for example. Note how all those hyperlinks, of course, they are app hyperlinks. So, okay, this was the help, but I want to see the help for a Scrabble, so control click. And then, well, I get the, like the help for the Scrabble command. So this is an example of how can we use hyperlinks, how POC uses hyperlinks in the help system. And I think it's quite comfortable. Another example. In POC, you can open several files, right? Or IO spaces, like we call them. So for example, there is a file foo.o. We open it like this. We can also open a memory-based iOS foo, and then another one bar, and then another one bus, for example. So now we have opened several IO spaces. Now, there is a command which is called info.ios that shows you all the IO spaces that are currently opened, along with some properties of them, right? You can see here that we have foo.o, which is a file, and then foo, bar, and bus, which are of type memory, right? And then we see the sizes and so on. Note that there are some hyperlinks here as well. For example, in the names of the IO spaces, we have hyperlinks, terminal hyperlinks, which are of the kind execute, which what they do is that they ask POC to switch to the IO space that you click, right? How would you do it manually? Imagine that now the current IO space is the number 3, and it corresponds to bus. If we wanted to go back to edit the file, we will need to use the ios command .ios 0, because it is the ID, 0 is the ID of the foo, of the file ios, right? So if we do it, then we are editing the last one, right? The file one. But we could also use the hyperlinks and just control click on this one, on bar, and now the current iOS is no bar, or bus, or foo, or whatever. And this is another example of execute hyperlink, right? Now, observe that we are also printing some hyperlinks at the right of those IO spaces, which is closed. It's closed. It's like a button, close. This is another example of execute hyperlink, and what it is for closing IO spaces. What is the normal, usual way to close an IO space? .close, and then again the ID of the IO space. So if we wanted to close, for example, the bar, right, the bar memory IOS, we will see close 2, right? And this will work. However, it's more convenient to come here and control click on this hyperlink, and look what happened. The command was executed implicitly, right? So if now we do info iOS, bar is gone. So this is also an example, of the kind of toolbars or toolboxes, right, and buttons that we are starting now to introduce, in the different poke commands and the outputs like info IOs, and stuff like this. Now, observe that the execute commands, they are very, they know that you may be editing something on the prompt. So, for example, if you are 2+ and then you say, oh, by the way, for example, imagine that then you say, okay, I want to see the integer at 23 bytes, and then you say, oh, wait a minute, but I am in foo. No, I wanted, to do it in the file instead. Okay, you control click here, and observe how it changed to this other IO, but your prompt in the read line buffer in the line is intact. Now this is the one in the file. So it is quite, they are, the way those hyperlinks execute in the poke program, they are in purpose, designed in order to be comfortable and careful, with the user. So those are all examples of the execute kind of hyperlinks, right? The execute a command, like if you will have typed it explicitly. But let's see another example, right? An example of the insert kind. So for that, now we are editing the file here, and one of the most useful poke commands is the dump command. And what is the dump command does? It dumps, a dump of all the bytes in the file. Now, observe that in the bytes values here, there are a lot of hyperlinks that poke printed. What do they do? Well, those are hyperlinks of the insert kind, and basically they are used here to insert the address in the prompt, the address corresponding to the byte that on which you click. What is this intended for? Usually you use the dump command to take a look around, right? And then you say dump, and then you get all the bytes there, and then you for example, you see, oh, this is, okay, what is this, right? You say, okay, I want to do something with those 3 integers. So then you will say, int map 3 integers at what address, at what offset. Now, if we did not use hyperlinks, the usual way to do it is to use the ruler and the rulers, basically. That is what they are here for, right? So we are interested in something that started at this position. So this is 30 in hexadecimal plus 4 in hexadecimal. So it is x 44, hexadecimal bytes. And this works, right? Well, actually, I wanted the one at 34. Yeah, it's more interesting. Yes. So here you go. Those are, we are getting those ones. Now, we could use the ruler. However, since we are using hyperlinks, we can use them instead. So we can just come here and say, okay, I want this one. Control, click. There you go. You got it there. Oh, actually, there is a bug here. This should be in hexadecimal. Well, okay. Yeah, let's fix it real quick. You see, this is the poke code because the dump command is not written in C, it is written in poke. And basically, we are getting here the so this is the fix. This is the fix. Let's install this new poke with the fix in it. Foo dump, and then we were saying in 3 at this position here. Okay, much better. You see? much better. Okay, and then we get it. So this is a hyperlink, an example of a hyperlink of kind insert. Now, as you can see, you have seen that if you write something and look at where the cursor is, right? Imagine that we are, okay, let's set, this, let's set change the integer at, I don't know what position to x, or the byte to this value. And then you can come here, back here and say, okay, which one? So now observe that the pointer is between this and there, right? In the readline editor, in the line. Now, if we click and insert hyperlink, it does the right thing. So it respects the rest of the line, it respects the previous portion of the line, and then it just does the right thing. So, yeah, you see, we just vandalized this file. So, this is one example of the insert hyperlinks that we are using in the dump command. And yeah, well, now we mentioned that we can, well, actually the dump command is written in poke, and it is very easy for the user, for the poke user, to create her own hyperlinks, and also to write poke programs that create their own hyperlinks. And also we have not seen any example of a closure hyperlink. So let me show you how. A poke program in general can print a hyperlink and create one as easy as this. You call hserver print hl for hyperlink. You specify a 1-character code for the kind, for example, execute, and a string that, the text, that will be the text for which the hyperlink attribute will apply, and then the command, right? In this case, 2 plus 2. Let's include a new line, and as you can see, this little poke program, it created this hyperlink click me. If we control click it, it executes the 2 plus 2, which obviously is 4, that we had, in this execute hyperlink. Now, we could, as easy as this, we could have created an insert hyperlink. This is how you create an insert hyperlink, specifying the I code for insert, and then it creates another hyperlink here. But in this case, for example, 1 plus, it creates an insert hyperlink. You see, and instead of executing it, it creates, it basically inserts it in the prompt, as we have seen. Now, of course, we can execute this, which is 5. So this one executes 2 plus 2, and this one inserts 2 plus 2 in the prompt. So then there is the third kind of hyperlinks, which it is the closure kind. This kind of hyperlink that I don't think we are using it yet in poke, the program, but it is available for poke code. Basically, you also use print hl, you specify C for closure, the button, click me, and then instead of a command, we include here something that I call a hint, right? That usually use square brackets, but this is free form, you can leave it empty, whatever. Say hello, right? And then as the last argument, it expects a function, a poke function that returns no value and gets no arguments. And this function will be executed every time that the user or someone clicks on the hyperlink. So in this case, let's use a lambda of a function that doesn't get arguments, doesn't return any, that prints hola, right? So then again, this printed in the terminal a hyperlink, and when we click it, observe what happens. First, it uses the hint, what I call the hint here, after the prompt, it prints it, and then it executes the function that we specified as the last argument. Why is this hint important? In my opinion, it is important because how does the user know, the user of Poke in particular, how does she knows when clicking on a hyperlink had any kind of effect? Well, in all cases, you basically can see something changing, right? So, for example, the execute, you see, what the command that was executed and the result. The insert one, obviously you see changes here because, you see stuff being inserted in your prompt. And for the closure one, you see this effect. You see a prompt being printed and the hint being printed, and then in this case, this is printed by the function that is being called. So I think it is important first that the user realizes that something is going on. That's why it is printing this prompt here and printing something. I think it is important that to provide hints which are, explicative enough to let the user at least have some idea what happened or what triggered this output here. But this doesn't change the fact that you can very well, if you choose to specify an empty string there, and then what you will see is nothing here, just the prompt. All right? So basically this is how a Poke program can generate one hyperlinks on each kind: execute, insert, or closure. Now, I think that this is very powerful, and we are rather excited about this because using especially the closure kind, using this, the user can actually write little Poke functions that will print toolbars and toolboxes, right? So, for example, if I wanted to print a toolbox with common functions that I want to be able to call easily, I could define my own function, Poke function in my Poke RC, or in a pickle or whatever, which will be toolbar. And then this toolbar, can print, a toolbar, basically, yeah. And when I am using the prompt, or the command line interface, all I have to do is to do toolbar or TB, or just T, if I choose to. And then I will have the toolbar there that I will then be able to click using the hyperlink. So, well, this was it for the little demo of how we are using hyperlinks in Poke, and I can certainly say that we are liking it very much. This is something that is pretty new. I mean, I have never seen anything like this before. I mean, clicking to communicate to the program, it was up to now something that you could see in text user interfaces or graphical user interfaces, but not in command line interfaces. So in that sense, this is something pretty new. I think it is very exciting, and I can only hope that we can achieve to standardize this somehow, so the distributions, they get support for this. Actually, the terminal implementations, they get support for this. Many of them already support this. But for the app protocol in particular, which is what gives Poke, this power of doing those things, those cool things, we will need for the app protocol to be standardized, and we will need for the distros and the terminals to actually make use of them, right? In the meanwhile, until that happens, we will continue using hyperlinks, terminal hyperlinks with the app protocol in Poke, and having fun as we are doing up to now. So this was all. Happy poking. Ciao, ciao.